Hi, today we're going to be learning about the area and perimeter of complex shapes. When finding the area of a complex shape, it is often necessary to decompose it. That means to break it up into smaller shapes. And then once you've broken up into smaller shapes, you're going to use the area formulae for the basic 2D shapes that you already know to calculate the area of the complex shape. To work out the perimeter of the complex shape, you're going to just add up all the sides around the shape. Now, before we go on to an example, I just want to remind you about the formula that you should know. So for a rectangle, the area is length times breadth. The perimeter is 2 times length plus breadth, or 2 lengths plus 2 breadths. For a square, the area is side squared. For the perimeter, it's 4 times side. For a triangle, the area is half base times height. For the perimeter, you add up all 3 sides. And for a circle, the area is pi r squared, and the circumference is 2 pi r, or pi times diameter. Then for a parallelogram, the area is base times perpendicular height, and the perimeter is 2a plus b, or 2a plus 2b. Then for a rhombus, the area is length times height, or half diameter 1 times diameter 2, and the perimeter is 4 times the length of a side. Then for a trapezium, the area is half times a plus b multiplied by height, where a and b are the 2 sides that are parallel to each other. And the perimeter, you just add up all 4 sides. And then for a kite, the area is half diameter 1 times diameter 2, and the perimeter is 2a plus b, or 2a plus 2b. Okay, now let's go and have a look at an example. In this example, you've been told that AB is 25 meters, AF is 17 meters, FE is 10 meters, and FG is 8 meters. And we need to calculate the area and perimeter of this shape. Okay, so let's go and have a look at how we would do this question. Okay, so over here, we have got our diagram. We've been told that AB is parallel to FC and parallel to ED. We've been told that AF is parallel to BC and FE is parallel to CD. We've also been told that this line over here is perpendicular to FC over there. We've been given the lengths of AB, AF, and FE, and then FG over here as well. Okay, so let's go and have a look at how we would work out the area and perimeter. Now, the first thing we have to do is we need to identify what types of quadrilaterals we're working with. So I'm going to be splitting this up into 2 shapes over here. So I've got this one over here, like that. That's my one shape. And my other one is this one over here. Like that. Okay. So first I need to identify what these 2 quadrilaterals are. So this orange one over here, ABCF, they've told me that AB is parallel to FC and AF is parallel to BC. That means that because I have 2 pairs of opposite sides parallel, this must be a parallelogram. So I can say AB is parallel to FC and AF is parallel to BC. And that was given. So therefore, that quadrilateral ABCF is a parallelogram. 2 pairs of opposite sides are parallel. Okay, so now I know what type of quadrilateral that is. I can then use what I know about a parallelogram to say that the opposite sides must be equal as well. So BC must be equal to 17, and that is 17 meters. And FC must be equal to 25. Okay, and the reason I know that is because opposite sides of a parallelogram ABCF are equal to each other. Okay, so now I know this is 17 over here, and this is 25. That whole length over there is 25. Okay, once I've done that, I can go and identify what the other quadrilateral is. So that's FCDE. So they've told me that FC is parallel to ED. And FE is parallel to CD. That's given. So therefore, FCDE is a parallelogram, and my reason again is two pairs of opposite sides parallel. Okay, so now I know that this is also a parallelogram, and that means that I can say that the opposite sides must be equal over there and over there. So that means that CD is equal to 10 and ED is equal to 25. Now I need to know those because when I'm working out the perimeter of this shape, I need to know the lengths of all the sides, and I'm not going to be able to use my normal perimeter formulae that I have for parallelograms because I'm not including all of the sides when I'm working it out. So that's why I'm saying what all of the lengths of the sides are. Okay, so the reason I can say this is because I've got opposite sides of a parallelogram, and that is parallelogram FCDE, and they must be equal to each other. Okay, so now I know that this over here is 10 and this is 25. Okay, now the next thing I need to do is in order to work out the area of this whole thing, I need to know this distance over here because that's going to be my perpendicular height, and I need to know this distance to work out the bottom one's area as well. So I'm going to go and work out what AG is using the Pythagorean theorem in this triangle over here, because if this is 90 degrees, it means that this angle over here must also be 90 degrees. So angle AGF is 90 degrees, and I know that because it's angles on a straight line. Okay, so if this is 90 degrees over here, I can use the Pythagorean theorem in this triangle. That means I can work out the length of AG. So I can say AG squared is equal to 17 squared minus 8 squared. And the reason I can say that is because of the Pythagorean theorem in triangle AFG with angle AGF equal to 90 degrees. Okay, and now we can go and work that out. So 17 squared minus 8 squared gives me 225. So therefore AG is equal to 15 centimeters. So this over here is going to be, or 15 meters, sorry. Okay, so this is going to be 15 over here. Okay, then I also need to work out the length of GE because I'm going to need that for working out the area of this parallelogram at the bottom over here. So doing the exact same thing, GE squared equals, but this time my hypotenuse is 10, so it's 10 squared minus 8 squared. Okay, so I have over here 10 squared minus 8 squared gives me 36. So therefore GE is equal to 6 meters. And this I could do because of Pythagorean theorem in triangle FGE with angle FGE equal to 90 degrees. Okay, so now I've got those two distances over there. Now I'm set up to go and be able to go and work out the area. Okay, so the area I'm going to be working out by doing the area of each parallelogram and adding them together. So to work out the area of parallelogram ABCF, I'm going to work out base times height. So base times height of ABCF plus base times height of parallelogram FCDE. Okay, so now let's go and substitute in. So for ABCF, my base is going to be 25. and the height is 15. Plus, for FCDE, the base is also 25, but now the height is 6. Okay, so I've got 25 times 15. That gives me 375. Plus 25 times 6 is 150. And that gives me 525 meters squared. Okay, so now I know the area of this whole shape. I worked out the area of that plus the area of that, and I added them together. Okay, now let's go and do our perimeter. So the perimeter we work out by just adding up all of the sides. So the perimeter is going to be 17 plus 25 plus 17 plus 10 plus 25 plus 10. Okay, so when you're working out the perimeter of a complex shape, you just work your way around the shape and you add up the sides as you go. Okay, so that's going to be 17 plus 25 plus 17 plus 10 plus 25 plus 10. That gives me 104 meters. Okay, so that's what you should get for that example, that your area is 525 meters squared and your perimeter is 104 meters. So just to go through again everything that we did. First, I identified the different types of quadrilaterals that I have in my shape over here. In this example, I had 2 parallelograms. So you prove what they are and you use what they are to help you to identify unknown sides that you maybe need to know to work out perimeters and so on. So over here, I worked out what BC and FC were based on the fact that it was a parallelogram, and the same thing over here, I worked out CD and ED based on the fact that that was a parallelogram as well. Then you'll also use Pythagoras if you need to help you to work out any missing sides as well. And then you can go and work out your area. To work out the area, you take each of the shapes that makes up the whole shape, and you work out the areas and then you add them together. Another possibility is to work out a shape's area and subtract areas of pieces that have been cut out. That's another option depending on the type of shape that you're working with as well. Okay, and then the perimeter, you just add up all the sides as you work your way around the shape. So over here, I added up each of these sides as I went around the shape. Okay, now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. In this example, you have got to work out the area and the perimeter of this shape. Now, in this particular case over here, you haven't been told anything about parallel sides or angles or anything like that. If they don't give you information like that, we can assume based on the fact that it looks like it is all perpendicular and so on, that these sides are perpendicular to each other. So you're working with rectangles and squares and so on here. And then you don't need to actually identify what the shapes are that you're working with. Okay, so I'm going to give you 2 minutes to do this example. Okay, so let's go through that example and see what you should have got. Right, so first of all, in this case over here, they haven't told you anything about parallel sides or anything like that, or angles or anything. So based on what we can see here, we assume that these are all perpendicular, and because that's what it looks like. And so we're working with rectangles and squares and so on. Okay, now there are two approaches that you can take for this particular example over here. You can work with it as two shapes that have been added together. So I'm going to divide it up like this, and I'm going to call this A and this B over there. Or another option is to work out this whole rectangle. So you can work this out over here, or you can draw this in over here, and work out the whole big rectangle and then subtract that piece over there. So there are two options you can use. I'm going to show you the method where we add the two A and B together, but that's not the only option. You could also have done the subtraction method as well. Okay, so what I'm going to do is I'm going to work out the area of A and B and add them together. To work that out, for A, I've been told that these are equal, so that means if this is 7, then this is also 7 centimeters. Okay, and over here, I've been told this is 7 and this is 12, which means that the opposite side over here must be the sum of the two. So 7 plus 12 is 19 centimeters over there. Okay, then over here, if this is 4, then this must be 4. And if this is 7, that must be 7. So then add them together, that gives you 11 for this whole side over here. Okay, so now I'm going to go and work out my area. So for A, it's a square, so it's going to be side times side, or side squared, plus for B, it's a rectangle, so I've got length times breadth. Okay, I'm just putting it in brackets and putting A and B just to help me to identify what I'm working with. Okay, so over here, for A, my sides are 7, so that's going to be 7 squared, plus for B, my length is 19 and my breadth is 4. So I've got 19 times 4. So that's 49 plus 19 times 4 is 76. And that gives me 125 altogether. So that's 125 centimeters squared. So my area for this shape is 125 centimeters squared. Now, like I said, you could have worked it out differently, where if you had taken the whole shape, that would be 19 times 11. So 19 times 11 minus this over here, which is 12 by 7. So minus 12 times 7, and that also gives me 125 centimeters squared. So either way, you would get the same result. Okay, so that's my area. Now we're going to go and work out the perimeter. So to work out the perimeter, we're just going to add up all the sides as we go around. So I've got 7 plus 12 plus 4 plus 19 plus 11. Okay, so over here, 7 plus 12 plus 4 plus 19 plus 11. And that gives me 60. So the perimeter is 60 and the area is 125 centimeters squared. Okay, so that's what you should have got for question A. Now we're going to go on to question B. In question B, you've been given a diagram where they tell you that BC is 13 centimeters, FE is 20 centimeters, DE is 8 centimeters, and CG is 6 centimeters. And you need to calculate only the area of the shape. I'm going to give you 5 minutes for this question. Okay, so let's go through that question and see what you should have got. So the first thing you have to do for this question is identify what types of quadrilaterals you're working with. So this quadrilateral over here at the top, ABCD, they've told you that BC is parallel to AD. We haven't been told anything about the other two sides. So all we can say over here is that this is a trapezium. So I can say that BC is parallel to AD. That was given. So therefore, ABCD is a trapezium. And I know that because I've got one pair of opposite sides parallel. Okay, then if we look at the other quadrilateral that we have here, ADEF, they've told me that the opposite sides over here are parallel and these ones are parallel as well, and that this angle F is a right angle. That means that this is going to be a rectangle. So here I can say AD is parallel to FE, and AF is parallel to DE, and that was given. And also I can say that angle F is equal to 90 degrees. That's also given. So therefore, this quadrilateral ADEF is a rectangle. And I know that because I've got two pairs of opposite sides that are parallel with one 90-degree angle. Okay, so one angle equal to 90 degrees. Right, now that I know what quadrilaterals I'm working with, I can use that knowledge to help me to work out the area of this whole shape. So remember, to work out the area of a trapezium, we have to take the opposite sides that are parallel to each other, add them, and multiply by the perpendicular height and halve it. But now, in order to work that out, I have to know what this length over here is. So I need to work that out by using the fact that this is a rectangle, so opposite sides are going to be equal. So I can say that AD is equal to FE, which is 20. So that's 20 centimeters. And I know that because it's opposite sides of rectangle ADFE or ADEF are equal. Okay, so this over here is 20. This whole length over there is 20. Okay, that means I can work out the area of my trapezium and I can work out the area of my rectangle and add them. Okay, so my area is half A plus B times the height. That is for my trapezium ABCD. Plus the area of the rectangle ADEF is length times breadth. Okay, so now let's go and fill in our value. So I've got half, and then for my trapezium, BC is 13 and AD is 20. They are the sides that are parallel, so they're the sides that I need to add. So it's going to be 13 plus 20 multiplied by my perpendicular height, which they told me was 6. Okay, plus the length and breadth of ADEF are 20 and 8, so it's 20 times 8. Right, so now we can go and work this out. So I've got half, then 13 plus 20 is 33 times 6, plus 20 times 8 is 160. Half times 33 times 6 is the same as 33 times 3. Half of 6 is 3, so it's going to be 99 plus 160. And that gives me 259. And that is centimeters squared. So your area for this shape over here should be 259 centimeters squared. Okay, so now let's go on to question C. In question C, you've been told that AB is 7 centimeters, BC is 25 centimeters, and AF is 18 centimeters. And you need to calculate the area and perimeter of this shape. I'm going to give you 5 minutes for this question as well. Okay, so let's go through that question and see what you should have got. So first of all, this shape over here is made up of a quadrilateral over here and another quadrilateral over here. So we need to identify each of these quadrilaterals. So if we look at this one first, they've told us that BC is parallel to AF. So I can say that this is a trapezium. So I can say over here BC is parallel to AF, and that is given. So therefore, ABCF is a trapezium. Okay, then with this one over here, it's the same thing. I've got EF is parallel to CD, which means that this is also a trapezium. So therefore, EFCD and the reason I can say that for both of them is one pair of opposite sides parallel. Okay, so now that I've identified both of these over here, I can now go and work out my area and my perimeter. So if you look over here, they've told me that this is equal to that. So if this is 18 over here, then this side over here is also 18. They've told me that these are equal over here, so this is also 7. And they've told me that these are equal, so this is also 25. So I've got the lengths of all the sides. So I can work out the perimeter because I already have all the lengths. And then to work out the area, I'm working with two trapeziums. So the area is going to be the area of a trapezium for this one over here. So that's half A plus B times the height for ABCF, plus this one also is half A plus B times the height and that is for EFCD. Okay, so now let's go and fill in our values over here. So first of all, for ABCF over here, my two parallel sides are these ones over here. So it's 18 and 25. So that's going to be my A and my B in my formula. And the height is the perpendicular distance between them. Now this side over here is perpendicular to these two sides, which means that this is my perpendicular height over there. So I'm going to have over here half, and then A and B are 25 and 18. So 25 plus 18 times my height, which is the perpendicular distance between those two sides, which is 7. And then for this one over here, it's going to be the same because I've got the same length sides. So 18 and 25 are also going to be my A and my B, and my perpendicular height is also 7 over there. So it's going to look exactly the same. Okay, so now over here, because these are exactly the same as each other, it's actually the same as having 2 times one of them. Because if you look over here, this is exactly the same as that over there. 25 plus 18 times 7, 25 plus 18 times 7, and they're both being times by a half. So they are identical to each other. So it's the same as having 2 times one of them. Okay, so when I have 2 times a half, these are going to cancel out. So it's actually just 25 plus 18 times 7. So 25 plus 18 is 43 times 7, which gives me 301. And that is centimeters squared. Okay, so now I've got my area. Now I need to go and work out my perimeter. So the perimeter for this shape, I'm going to work out by just adding up all the sides as I make my way around the shape. So I've got 18 plus 7 plus 25 plus 25 plus 7 plus 18. And that gives me 100 centimeters. So you should have found that the area for the shape is 301 centimeters squared and the perimeter is 100 centimeters. Okay, now let's go on to the last question for today. In question D, you've got a circle and that circle has a piece cut out of it in the shape of a quadrilateral JKLM. You've been told that JL is 20 millimeters and it passes through the center of the circle over there. And KM is 15 millimeters. You need to calculate the shaded area and round off to 2 decimal places. I'm going to give you 4 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so first of all, for this question, you had to identify what type of quadrilateral this is over here. So they told you that JK is equal to JM, and that ML is equal to KL, and that was given. Now, because those are equal, we can say that therefore this is a kite. So JKLM is a kite. And my reason is that there are two pairs of adjacent sides equal. Okay, so now because I know that it's a kite, I know that the formula for working out the area of the kite is half diameter 1 times diameter 2. Now they gave us the lengths of the two diameters. They told us that JL is 20 millimeters. So this over here is 20. And they told us that KM is 15 millimeters. So this over here is 15 millimeters. Okay. Now, to work out the shaded area in this diagram, what we need to do is take the area of the circle and subtract the area of the kite. Okay, so to work out my area, it's going to be the area of the circle, which is pi r squared, minus the area of the kite, which is half diameter 1 times diameter 2. Okay, so now in this example over here, they told me that JL passes through the circle, through the center of the circle. You can see that in the diagram. So JL is the diameter of the circle. So they've told me that the diameter is 20 millimeters. That means that the radius is going to be half of 20 millimeters, so it's 10 millimeters. So it's going to be pi times 10 squared minus pi times the diameters I need to multiply are 20 and 15. So half times 20 times 15. Okay, so over here, pi times 10 squared is 100 pi, minus half times 20 times 15 is going to be 150. So I have 100 pi minus 150, and that gives me 164.16 millimeters squared. And that's what you should have got for question D. Okay, and that is how we calculate the area and perimeter of complex shapes. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.